start to know how it looks like the exponential function. If you remember, before we start, the linear equations, which is, for example, if we have 2x plus 4 equal 5. So this is a linear equations because the x here is the linear. Also, this is linear. If we have x squared plus 4x plus 5 equals 0, this is quadratic equations. Now, we need to know how it looks like the exponential equations. The exponential equations, for example, it's equations and the x is going to be as an exponent, and we have to know how to solve that. For example, if you have 2 for exponent x plus 5 equal 0, you can't solve this one exactly like the linear. There's a method to solve it by using the rule of exponents. We'll learn that. Let's change this one to 4. Here's another example. If we have 2 to the exponent x plus 5 equal 4. You see, the variable exists in the exponents here. So that's why we're going to call this one exponential equations. These two examples, how it look like the exponential equations. Again, now if they ask you about, because we're going to use that when we graph the exponential equations, how to evaluate the exponential equations, you're going to use exactly the same method. For example, if you have f of x equal 2 to the exponent x, and they ask you find f to the negative 1. F of x, this is f of x, but check here, your equations here of the function f of x equal 2 to the power x. That means this is called exponential equations. Why? Because the variable x is an exponent. How to evaluate that? We're just going to plug in negative 1 on the top here. So it's going to be 2 to the negative 1. Then you have two options. You can use the calculator here to find how much is going to be 2 to the negative 1. Or if you want to use the rule of exponents, and I'm going to show you both. We're going to write down the important rules here just to refresh your memory. So if you want to use the calculator, just be careful here. I'm going to find 2 to the exponent negative 1. So here's 2. Now exponents, here's the negative, always the negative sign, use this one, negative 1. So the result is going to be 0.5. That means this one is going to be 0.5. The same thing if you want to use the rule of exponents. Let's find the result here again with another example. If they ask you to find f to the 3, so it's going to be 2. I'm going to plug in instead of the x3. So that means going to be 2 times 2 times 2 is going to be 8. If they ask you find f to the 5 over 2. So now we're going to plug in 5 over 2 here. So it's going to be 2 to the exponent 5 over 2. This is really important, even if you want to use the calculator. So let's check that. If they ask you find 2 to the exponent 5 over 2. So here's the 2 to the exponent 5 over 2. I'm gonna write down 5 divided by 2. 5 divided by 2. Enter. So the result is going to be 5.65. This is really important if you want to graph the exponential function, 5.65. Let's do another example. If they ask you find f to the 4.9, so now we're going to plug 2 to the exponent 4.9. 2 to the exponent 4.9, and the result is going to be 29.5085. 2 to the exponent 4.9, and it's going to be 29.85. This is really important to evaluate in case if they ask you, find that, like they give you equations and you have to graph it. And we will take an example about that, how to graph the exponential function. Before we move on, here's the exponential function, how to graph it. I'm going to give you some rules about that. Let's take the exponent rule, which is really important. We're going to use it when we're trying to solve the exponential function. The exponent rule, if you remember, if you have any number with exponent n times a number, so let's do it here on this side. The exponent rule, it's really important. If you have a number with exponent n times a number with exponent m, is going to be the number n times n plus m. N plus m. You're just going to add the exponents. The second rule, if you remember that, if we have a to the exponent n, divide by a to the exponent m. So it's going to be a, always the top minus the bottom, n minus m. This is the second rule. The third rule, if we have a to the exponent n and all to the exponent m. That's the difference between rule number 1 and rule number 3. Rule number 1, we have two numbers, but rule number 3, we have one number with two exponents. So in this rule, we're going to multiply the exponents. So it's going to be a n times m. Number 4, these are the important rules. We're going to use it when we try to solve the exponential function. If you have a number with exponent 0, always going to be 1. And if you have a number with exponent 1, that means it's just the number. So if there is no exponents, that means it's 1. If there is no exponents, that means the exponent is 1. The last rule, if you have a number with negative exponents, so it's going to be 1 over the number with positive exponents. We will use this rule a lot, especially this one and this one. So you have to know how this is the rule of exponents. We will use this one when we're trying to solve the exponential equations. So the exponential function, if you want to graph exponential function, let's take some rules. About how to graph exponential function. So here's the exponential function. Let's take the general form. F of x equal a to x. A, which is any number, that's a number with x, that's why we call it exponential function. And a, there's a condition a is supposed to be not equal to 1. Because 1 for any number is going to be 1. 1 for any number is going to be 1, that's why we're not gonna graph it. So we have, and a is supposed to be positive number because we can't use a negative number. So here's another condition, a is supposed to be greater than 0, not 1. So here's two conditions. If you see these two conditions, that means this is an exponential function. So now we will learn how to graph it. We have two options to find the graph. If a is a number greater than 1, this is the first condition. And here, if A is a number between 0 and 1, that means a decimal number. We will see a graph here and we will see a graph here. So now, before we start the graphing, you have to check these conditions. This is the exponential function. I have to make sure A not equal to 1, any number 2, 5, 6, and I have to make sure A is a positive number, that's mean greater than 0. If these two conditions satisfy, that means this is an exponential function. So now, in the next part, I'm gonna have to make sure the A, which is the number here, greater than 1. If the A is greater than 1, that means when I want to graph it, my graph is supposed to be look like this. This is when A, my graph is supposed to be like this. This is if A is greater than 1. That means 2, 3, 4, 5, 6 million to the power X. If you want to graph it, your graph is going to look like this. And always the domain is going to be from negative infinity to infinity. And the range is going to be from 0 to infinity. Always you can choose this domain and range. Now, the second condition, if A is between 0 and 1, that means a decimal number. So the graph is going to be, if it's a decimal number, the graph is going to be the opposite from this one. It's going to be a line like this. And if you see this line on both sides is not going to cross the x coordinate because we can't use a negative number. We're not going to get a negative number here with the y value, always positive. That's why the domain always from negative infinity to infinity, and also the range from 0 to infinity. You see the range from 0 to infinity, that's means my function is going to be always on this side, on this part from the coordinates, and here are the same thing. So you have two options. If it's a decimal number like 0.5, 0.3, if I want to graph it, my graph is going to be look like this. If A is a number just greater than 1, like 2, 3, 4, so if I want to graph it, my graph is going to be look like this, and here is the domain and the range. This is how to see the exponential function. For that, we're going to take an example, a simple example. If they ask you to graph an exponential function, so graph this function, f of x equal 5 to the exponent x. First of all, I need you to write down these, then we're going to move on. Let's check how we're going to graph the exponential function. So first of all, I have to analyze this one. My domain and range always from negative infinity to infinity. So I'm not going to care about if I choose negative numbers and positive numbers. So always choose negative numbers and positive numbers. The second thing, 5, I have to make sure A is not equal to 1. This is the exponential function. So I have to check where is the A. The A is 5, which is not equal to the 1. This is the first thing. A greater than 0? Yes, 5 is greater than 0. So first of all, 5 not equal 1, and 5 is greater than 0. So these two conditions satisfy. That means this is exponential function. Now I need to check which graph is going to be my graph. Look like this one or this one. A is greater than 1. Yes, 5 is greater than 1. That means my graph is going to be look like this one. So let's check that, how we're going to graph it. We're going to use the same process. The first thing, my domain is from negative infinity to infinity. That means I can choose negative numbers and positive numbers. So let's choose -1, 0, 1, 2. You see, I choose negative number, positive number, 0, and positive numbers. So it's up to you. 3 numbers is going to be enough. Now, to find the y value, we have to plug in -1 here. So I'm going to plug in, it's going to be 5 to the exponent -1, which is equal 5 to the exponent -1. If you use the calculator, it's going to be 1/5, which is going to be 0.2. That means the first point is -1 and 0.2. Again, let's see how it looks like, because this is important if they ask you to graph it. We're just going to plug in 5, and we're going to plug in -1, -1, 5 to the exponent -1, and it's going to be 0.2, 0.2. The second number is going to be, we're going to plug in 0. 5 to the exponent 0 is going to be 1. So the second number is going to be 1. The third one, we're going to plug in 1. 5 to the exponent 1 is going to be 5. That means here is going to be 5. 2 now. We're going to plug in 2 instead of the x. So it's going to be 5 to the exponent 2, and it's going to be 25. So here it's going to be 25. So we're going to plug in 5. Let's do it again here. So you will know what I'm doing. 5 to the exponent 1, which is going to be 5. That means this point is going to be 0 and 5. The third point, which is 1, is going to be, 5 to the exponent 0 is going to be 1. So it's going to be 0, 1. 5 to the exponent 1 is going to be 5. That means it's going to be 1 and 5. And the last one is going to be 5 to the exponent 2 is going to be 25. So it's going to be 2 and 25. So we get the point. Now we're just going to graph it. It's not going to be that much hard. So you will see our graph is supposed to be similar to this one. So let's check that. This is graph similar, like similar graph here. So the first point is -1 and 0.2. So let's say this is -1 and 0.2. So it's going to be, let's say this is the 1, 2, and keep going up. 0.2 is going to be here. That means the graph like this. 0, 1. So here is the 0 and here is the 1. So here is the second point. 1, 5, 1, 1, 2, 3, 4. This is the 5. So it's going to be 1, 5 here. So you will see the graph goes up. 2 and 25 is going to be really goes up again. So if you check that, the graph is going to be similar to the graph here. Why? Because 5 is greater than 1. So this is, I have general form about how my graph looks like, and we get exactly the same one. Like the graph like this. If A is between 0 and 1, like this example, so for example, like if you have function like this, let's check that. 2. That means 0.5 or 0.2 to the power x or half. Let's check this one. For example, if your function f of the x equal 1/2 to the power x. If you want to graph this one, check the a. The a equal 1/2, which is 0.5. That means a between 0 and 1. So the general graph is going to be like this. So when you graph it, it's going to be like this one. That's why you just have to be careful when you graph it. and it's going to be easy. Choose any number, plug in using the calculator to find the y value. 3 points is going to be enough. Choose the 3 points, 1 negative, 0, and 1 positive. Plug in these in the function and to get the y value and graph it. Solving linear equations, which is really important. I'm going to give you an example about that. So 1/9, this is the first example, to the power x equal 729. Now they ask you to solve this one. That's the only one they're going to ask you. Solve these equations. So you have to know this is exponential equations because I have 1/9 and here's the exponent x, which is a variable. Now I need to find the value of x. So the first thing I'm going to do is using the rule of exponents. So I'm going to, one of the rule of exponents, it says, if you have a number with negative exponents, is going to be 1 over the number with positive exponents. So it's the same thing. If you have 1 over the number with positive exponents, I can rewrite down again to a number to negative exponents. I'm going to use this rule here. 1/9, I'm going to write down the positive exponent here is 1. So I'm going to write down 9 to the negative exponents. And here is x equal 729. 729, it's 9 times 9 times 9. So it's 9 cubed. So 729, I can write down 9 cubed. You see, I used this rule here. I just bring back the 9 on the top and I change the exponent to negative. It's going to be negative exponents. Now, the next rule, I'm going to use it here. This side, the right side, is going to be exactly the same. On the left side, there is a rule that says if you have a number with exponents and everything with another exponent, you can multiply the exponents. A n times m. So I'm going to do this one here. I have 2 exponents here, -1 and x. So it's going to be 9, -1 times x is going to be -x equal 9 cubed. Next rule, which is the important rule, we're going to use it a lot. Every time when you have equal exponents, let's write down, this is really important. Every time when you have equal exponents, that means you have equal base. The same thing, if you have equal bases, that means you have equal exponents. This rule is really important. If you have equal exponents, that means you have equal bases. If you have equal bases, that means you have equal exponents. That's why I write down this arrow. You can use it both. Now check here. I have equal bases. If I have equal bases, that means I have equal exponents. So I'm just going to write down -x equal 3. I have equal bases, that means I have equal exponents. Now I need to find the value of x. So the coefficient here is -1. So I'm just going to divide both sides by -1. So from the left side, -x divided by -1 is going to be x. 3 divided by -1 is going to be -3. So you see, only this one is the new rule. The first thing, I convert this side, the left side, from the positive exponents to a negative exponent. And I simplify 729 as a 9 cubed, because 729 is 9 times 9 times 9, which is 9 cubed. Then I have another rule. It says if you have a number with 2 exponents, you can multiply these 2 exponents. So it's going to be 9 to the negative x. And from the right side, 9 cubed. If you have equal bases, that means you have equal exponents. So here's equal bases. I'm just going to take the exponents, negative x equal 3. Then next step, we're going to divide both sides by -1 because we need to find the value of x, not negative x. So it's going to be -3. So this is the solution. X equal -3. Equations. Now we're going to do exactly the same steps, but with different example. So if you have 4 to the negative x equal 1/256. So we're going to do the steps here and which rule I'm going to use on the right side. The first thing, I can't do anything here because I have exponents with a number with negative exponents. So leave this side. I'm going to work on this side because it's easier to work on this side. The first rule, the exponent here is 1. So I'm going to use the same rule. If I have a number with negative exponents, it's going to be 1 over the number with positive exponents. So I'm going to bring back. I have 1 over a number with positive exponents. I'm going to write down the number with negative exponents. That means this side is going to be 256 to the -1 equal 4 to the negative x. Next step, I have to simplify this one to write down this as a number with positive exponents, So how I'm going to do that? I'm going to do that by 256. If you divide it by 4, how much is going to be? I have to simplify it. 256 divided by 4 is going to be 64. So 64 divided by 4 is going to be 16. 16 divided by 4 is going to be 4. 4 divided by 4 is going to be 1. That's mean 256, I can write it down as a 4 to the exponent 1, 2, 3, 4. So instead of 256, I'm going to write down 4 to the exponent 4. So here is 4 to the exponent -x equal 4 to the exponent 4 and everything to the -1. Now, next step, we're going to use the rule I have number with 2 exponents. So there is a rule that says if you have number with n and another exponent is going to be a number with n times m. You're going to multiply the exponents. I'm going to do that here. So 4 to the -x equal 4 times -1, -4. I'm done. I have same bases because the rule says if you have equal base, that means you have equal exponents. Now, if you check here, I have equal bases. That means I have equal exponents. So I'm just going to write down the exponents. -x equal -4. Last step, I need to find the value of x, not -x. So I'm going to divide both sides by -1. So x is going to be equal 4. You see, we found the solution by using all these steps. This is the third example. It's really important. So now if we have 4 to the exponent 8 minus 2x equal to 5, 6. Again, we just need to get the equal bases. So that means we have equal exponents. The exponent here is 1. So I need to analyze this number. The exponent here is 1. So what I'm going to do, I'm just going to say 2, 5, 6. If I divide it by 4, it's going to be 64. Divide 64 by 4 is going to be 16. 16 divided by 4 is going to be 4. 4 divided by 4 is going to be 1. So I can write down 256 as a 4 to the exponent 4. So I'm going to write down this one here. 4 to the exponent 4, and here is the 1. Equal 4 to the exponent 8 minus 2x. Now, next step, I have a number with 2 exponents. So I'm going to use the rule. It says if you have number with 2 exponents, you're just going to multiply the exponents, n times m. I'm going to use this rule here. So it's going to be 4 times 1 for the exponent 4 equal that. Left side, just write down 4 to the exponent 8 minus 2x. Not going to do anything with the left side. Now, if you check this one, I have equal bases. There's a rule says if you have equal base, that means you have equal exponents. So I have equal exponents. So I'm just going to write down the exponents. 8 minus 2x equal 4. Now this one is easier to solve. So I'm just going to move the 8 to the other side. So minus 8, minus 8. Cancel these. So the leftover is negative 2x equal 4 minus 8 is going to be negative 4. Now the last step, dividing both sides by negative 2. So x is going to be negative 4 divided by negative 2 is going to be 2. That means this is the solution for this example. Now, how are we going to solve this one? So the first thing, I have number with the exponents. I can't do anything on this side. But how I'm going to get equal bases, like the previous example. The previous example, if you check that, we already have 4 here. So when we analyze the second number, 256, we divide it by 4. And when we analyze it, we can write down 256 as a 4 to the exponent 4. That's why we get 2 equal bases. That means we have equal exponents. But if you check the new example, I can't write 27 as a 9 to the exponents. And I can't write down the 9 as a 27 to an exponent. So what I'm going to do here, I'm going to analyze both sides. So let's check here. 9 is 3 times 3. So I can write it down as a 3 squared. So I'm going to write down here 3 squared, and here's the exponent 6 plus 3x equal 3 squared, and here's the exponent 6 plus 3x. On the other side, 1 over the 27. It's a 3 times 3 times 3. So I can write it down as a 3 cubed. So I'm going to write down 3 cubed here. Now you see we have equal bases. But before that, I need to move this number on the top by using this rule. If you have number with negative exponents, it's going to be 1 over the number with positive exponents. I have this part, I'm going to write down the other part, the right side, the left side. So here is going to be 3 to the negative 3. On the right side is going to be exactly the same, 3 to the exponent 2 and 6 plus 3x. Now you check, we have equal bases. So when you have equal base, that means you have equal exponents. So what I'm going to do, I'm just going to write down the exponents, which is 2, 6 plus 3x equal negative 3. This is linear equations. How we're going to solve it? We're going to distribute here. 2 times 6 is going to be 12, plus 2 times 3 is going to be 6x equal negative 3. Move the 12 to the other side. So I'm going to say minus 12, minus 12. Cancel these. So the leftover from the left side, 6x equal negative 15. Then next step, we're going to divide both sides by 6. So it's going to be x equal negative 15 over 6. Can I simplify it? Yes, you can simplify it by dividing both by 3. So x is going to be negative 15 divided by 3 is going to be negative 5. 6 divided by 3 is going to be 2. This is the final result. So the same process, but I have to analyze both sides so I can get equal bases. There's a rule that says if you have equal bases, that means you have equal exponents. So we're going to get equal exponents. And the rest is going to be just solving as a linear equations. Distribute here, then move the 12 to the other side by minus 12 from both sides. The leftover 6x, divide both sides by 6. Then simplify. Always when you have solution like a fraction like this one, you're going to simplify it and check if you can simplify it. In this case, we can simplify it by dividing both by 3. So 15 divided by 3 is going to be negative 15 divided by 3 is going to be negative 5. 6 divided by 3 is going to be 2. This is going to be the solution for this exponential function or equation. So see, we have x's on both sides, but we can't do anything. We're going to use exactly the same process. We need to get the same basis. So I'm going to analyze this part, and I'm going to analyze this part. So let's check that here. 8, which is, we can write down 8. It's 2 times 2 times 2. So I'm going to write down 8 as a 2 cubed. 16 is 2 times 2 times 2 times 2. So I'm going to write down the 16, 2 to the exponents 4. So I'm going to write down these two numbers here. 8 is 2 to the cube, and here is the exponent 2x minus 1 equal 16 is 2 to the power 4, and here is the exponent 3x plus 4. Now, if you check in this case, we have equal bases. That means we have equal exponents. When you have equal base, that means you have equal exponents. So I'm just going to take the exponents from both sides as 3, 2x minus 1 equal 4, 3x plus 4. Then next step, we're going to solve this linear equations by distribute here and distribute here. 3 times 2x is going to be 6x minus 3 times 1 is going to be 3 equal 4 times 3 is going to be 12x. 4 times 4 is going to be plus 16. Move the 12 to this side and the number to the right side. So I'm going to add 3, add 3. Cancel here. The left over here is 6x equal 12x plus 19. Next step, you're going to move the 12 to the other side. So minus 12x minus 12x. Cancel these. 6x minus 12x is going to be negative 6x equal the leftover from the right side is 19. Last step, divide both sides by negative 6. So x is going to be 19 over negative 6. Can you simplify it? No. So this is the final result. 19 over 6, negative 6. That's it for this example. So here is the thing with the compound interest. If they ask you about, if they're telling you deposit or invested, that means this is P with these two formulas. A, which is the future amount, that means how much is going to be in the future. If you open a bank account and you're going to invest like a certain amount of money, how much is going to be in the money in your bank account in the future, like in 10 years. So T is the time, A is the future amount, P, which is the deposit or the invested, R is the rate of interest. They're going to give you rate of interest like 5%, 10%, it depends about. And here is the compound. This is the compound, which is the important part, because it's going to tell you which formula you're going to use. If they're telling you compound annually, that means n equal 1. And it's already telling me, go ahead, use this formula. Also, if they're telling you compound similarly, that means n equal 2. And they're telling you, go ahead, use this formula. Quarterly, that means n equal 4. And they're telling you, go ahead, use this formula. Monthly, the same thing, n equal 12. And I'm going to use this formula. Daily, which is n equal 365, and I'm going to use this formula. So n, if one of these, they're telling you annually, quarterly, monthly, daily, you have to know to use this formula. If they're telling you n is continuously, that means I'm going to use this formula. So here's the difference between these two formulas. It depends about compound interest, the n. If it's annually, semi, quarterly, monthly, daily, you have to use this formula. If it's continuously, you have to use this formula. So let's start. I need you to write down these before we start doing an examples about the compound interest. Here they're telling you 1,972 invested. So here's the thing, to make everything easier for you, you can write down all the information on the side. So they're telling you 1,972 invested. That means invested is P. So I'm going to write down P equal 1. This is P. Invested. I'm going to invest 1,972 for 12 years. That means the time 12 years. So T equal 12 at 4%. That means the rate equal, rate of interest is 4%. Here's the thing, 4%, that means 4 divided by 100. So it's going to be 0.04. I'm going to use this one. I'm not going to use 4 because it's 4%. Compound quarterly. So check, we have two options. If they're telling you compound quarterly, that means n equal 4. So I'm going to write down n equal 4, and I'm going to use this formula. So A equal P 1 plus R over N Tn. How much the future amount? They ask you to find the future amount, which is A. That's what they're going to ask you to find. So A equal, we need to find the future amount in your account. If you invest 1,972 for 12 years at 4% compound quarterly, that means they're going to give you interest every 4 months. For 12 years, every 4 months, you're going to get an interest. Let's check how much is going to be in the account after 12 years. That means the future amount. So I'm going to plug in all this information here. Here is the future amount, the deposit of the invested 1,972, open parentheses, 1 plus, the rate is 0.04 over, the n is 4, time is 12, t times n, so 12 times 4. So you see, the other side, the right side, all the numbers on the right side and the variable on the left side. So this is going to be easier to find. It's up to you. You can use calculator. You're just going to simplify it step by step. Everything is going to be fine. I'm not going to say no, but I need you to know how to use the calculator at the same time. So check what I'm going to do here. I'm just going to simplify it more. 1,972, 1 plus, divide this one, 0.04 by 4 is going to be 0.01. 12 times 4 is going to be 48. Simplify it more. A is going to be 1,972. 1 plus 0.01 is going to be 1.01. And here's the 48. Now it's easier, even if you're using the calculator, you're not going to do any mistakes. So let's check how much is going to be the result. I'm just going to plug in these here. So 1972 parentheses 1.01, close the parentheses, to the exponent 48. Press enter, so it's going to be 3,179.31. Because I'm going to round the number. I got 3, let's do it, 309. I'm gonna round the number to 2 decimals. So the result, of course, they're gonna ask you on the test to round the number to how many decimals. So 3179 point, I'm going to round down to 2 decimals. So it's going to be 31. So that's mean if you invest 1,972 with the rate of interest 4%, compound quarterly, that means they're going to give you interest every 4 months. For 12 years, the future amount is going to be 3,179. So the second example, they ask you how much should be invested. That means we need to find the P. How much should be invested? That means the P is our goals. We need to find the P. For 4 years, that means T equal 4 at 3%. So the rate is going to be 3%. Always, you're not going to write down 3%. That means 3 divided by 100. So it's going to be 0.03. Compound monthly. You see, this is really important. The compound monthly, they tell you compound monthly That's mean n equal 12. And I'm going to use this formula. So I'm going to write down the formula. A equal P 1 plus R over N Tn. So I'm going to use this formula. I have all the information, but we're missing to grow to 11,000. That means how much you're going to invest to grow to 11,000. So the 11,000, that means it's the future amount. So the future is 11,000. So now we need to find the P. So I'm going to plug in all this information here. Here's the 11,000 equal P 1 plus R is the rate of interest, which is 0.03, divided by N, which is compound monthly, 12. T, which is the time, 4 times 12. I have all the information now. I just need to find this is the variable. So I'm going to simplify both sides. If you check the left side, it's already simplified, so I can't do anything here. So 11,000 equal P. I'm going to simplify this part. So 0.03 divided by 0.03 divided by 12 is going to be 0.00025. 0.0025. That means going to be 1 plus 0.0025. You see, I'm simplifying these two numbers first. Step by step. 4 times 12 is going to be 48. Then next step, what I'm going to do, add these two numbers. So here is 11,000 equal P is going to be 1 point. When you add these two numbers, 0.025 to the exponent 48. Now I need to find this part, how much is going to be, because here is the variable. I can't do anything now. I just need to simplify, keep going, simplify this part. So let's go back here and check how much is going to be. 1.0025 to the power 1.0025 to the power 48. And it's going to be, here's the P, going to be 1.127328021. I wrote the whole number. This is the 1.0025 to the power 48. And the left side is going to be exactly the same. Now I need to find the P, which is the variable. So I'm going to divide both sides by the number with the variable, by 1.127328021, 1.127 328.021. These cancel. The leftover here is P equal. Now let's divide 11,000 divide by this number, and is going to be 9,757 point. I'm going to take also 2 decimals, 59. That's mean if you invest 9,759.59 for 4 years, compound monthly. Compound monthly, that means they're going to give you interest every month. With the rate of interest 3%, your future amount is going to be 11,000. So that's our goal. This is the second type. If they ask you to find the invest or the deposit, you're going to do exactly the same steps every time if they ask you. So now you have two types. The first example, if they ask you to find the future amount. The second example, if they ask you to find the deposit or the invested, you're going to do exactly the same thing. So this is the second type, exactly the same process. Suppose 4,000 is invested. Invested, that's mean they're telling you this is the P. P equal 4,000 is invested at 7% interest. That's mean the rate is 7%, which is equal 7 divided by 100. So it's going to be 0.07. This is the second part. So we have the deposit, the invested, we have the rate. Compound continuously. This is the important part. If you go back here, the compound, if it's continuously, I'm going to use this formula. So I'm going to show you how to use this formula. That's mean I'm going to use A equal P, E, and RT. Let's keep going. How much will be in the account? That's mean we need to find how much is going to be in the account. That's mean the future amount for after 3 years. That's mean the time equal 3. This is the invested. This is the rate of interest. A equal, we need to find the future amount, and the T equal 3. So A equal, the deposit is 4,000. This is E, it's a function. I'm going to show you how to find the result. This is E function. We're going to study this one on section 4.4 also, how to find the solution for this one. But also, in this case, I'm going to use the calculator. How much the R? The R is 0.07, and the time is 3. So now, A equal, I'm just going to use the calculator. We can simplify this part if you multiply it, or you can leave it like this, it's fine. So let's see how we're going to use the calculator to find the solution for this example. Let me clear everything. So now how to plug in these. Here's the important part. I need you to focus here. 4,000. Here's the 4,000. Let's write down the E function. Where is the E function? You have to press the second function and the len. If you check the len function, there is a small, the second function, e to the x here. That means I need to use this one. So the second function and the len, you see, is going to be e to the exponents. Is going to be e to the exponents. So this is really important. So now type the exponents, which is 0.07 times 3. 0.07 times 3. Press enter. This is going to be the result. The result is going to be 4,934.71. So this is really important because you can't find it until you use the calculator. How to type the E to the X? Let's do these steps again. So 4,000, you're gonna press the second and the ln, then type 0.07 times 3, 0.07 times 3, or parentheses with 3, is going to be, here's the result, 4,934.71. And be careful, always they're gonna ask you to round the number. It depends how many decimals is going to be, 3 or 4, or it depends about 110. So you have to be careful. With this example, they didn't ask you. So this is the future amount if it's compound continuously. So the last example, if they ask you to find the rate of interest. Let's do this example. which is also an important example. Now let's check this one. We'll be asked to find the rate of interest. Find the required rate of interest. Must mean we need to find the rate of interest. So R is going to be the one we need to find. For 5,200 to go to 6,500. That means this one will go to this one. So this is the invest or the deposit, and this is the future amount. That means P equal 5,200 and the future equal 6,500. If the interest is compound quarterly, that means they're telling you N equal 4, and I'm going to use this formula P1 plus R over N Tn. Because it's compound quarterly, that means I'm going to use this formula. I have the future, I have the deposit. One, I need to find the rate of interest, the compound quarterly, that means N equal 4 for 5 years. So the time equal 5. So I'm going to plug in this information here, and I need to solve it to find the rate of interest. The future is 6,500 equal, the initial is 5,200. 1 plus the rate, we need to find the rate. The compound is 4, Tn, the time is 5, and the N is 4. Now, I'm going to multiply these two numbers, it's going to be 20. But before that, here's the variable. So let me cancel this number, because any number with the variable, I can cancel it by dividing both sides by 5,200. So I'm going to divide this side and this side by 5,200. And here also by 5,200. Cancel these. 6,500 divided by 5,200, I think it's going to be 2.5. 6,500 divided by 5,200 is going to be 1.25. 6,500 divided by 5,200 is going to be 1.25. So this one divided by this one is going to be 1.25. And the left from the other side is going to be 1 plus R over 4 to the 20. Now let's check the second step, the next step. This one is for power 20. So I need to cancel the exponents. How I'm going to cancel the exponents? So here's a hint. If you have x squared equal 5. To cancel the squared, we're going to take the square root for both sides. So I'm going to do the same thing, because the root cancel with the 2 is going to be just x equal the square root of 5. I'm going to do the same thing here. I'm going to take the 20th root for both sides. That means it's going to be the 20th root here for 1 plus R over 4 to the 20 equal the 20th root for the other side, 1.25. That means I'm going to take the 20th root for both sides. On this side, you don't cancel these. The leftover just 1 plus R over 4. Now, what's the 20th root for 1.25? Let's use the calculator to find the 20th root for this number. The 20th root, how are we going to find the 20th root? So we're going to press math, and here's the n root. Enter. I have to write down the 20, you see it as a root. Then I'm going to write down the number 1.25. So it's going to be, here's the 20th root, 1.01121. Now we're done from this step. Now this is a linear equations with the rational part. That's me rational equations. How to find the solution? We're going to multiply everything by 4 because this is the problem here. So this one by 4. So this number is going to be here because I'm going to multiply this one by 4. 1.01121 times 4 equal 1 times 4 plus r over 4 times 4. Cancel these. This number times 4 is going to be 4.0448487 equal 1 times 4 is going to be 4 plus r. I'm just going to move this number to the other side. So minus 4 from here, minus 4 from here. Cancel these. Left over here is r equal 0.04487. Now, if they ask you to round it to the nearest tenth, you're just gonna round this one to the nearest tenth. So this is the rate of interest, r equal, you're just going to multiply this one minus 4 and multiply, I think they ask you by 10, by 100 to convert it to the percentage. So I'm going to multiply this one by 100. That means r is going to be by 100 by another 10 is going to be 4.487. So percent. This is the solution. 4.487. So this is the last type. If they ask you about how to find the rate of interest, you have to do these steps. These examples are really important. And I gave you all the types. If they ask you about to find the future amount, if they ask you to find the percent, which is the deposit uninvested, if they ask you to find the rate of interest, and the last part, if you use the compound continuously, also we did an example. So all the types, now we have it. One more type we have, we're not gonna take it until we cover section 4.4.